this exercise, let A and B be two sets, and f be a function from A to B. We want to prove that f is injective if and only if, given any two arbitrary subsets U, V of the set A, the image of their intersection is always equal to the intersection of their images. So let us start from the only if part. To this end, we assume that f is an injective function from A to B. Also recall that when we discuss the definition of images and preimages, we have already seen that one direction of the desired set identity always holds, no matter if f is injective or not. That is, the image of the intersection is always a subset of the intersection of their images. Thus, to prove the desired identity, we only need to prove the other inclusion. So let us assume that y is an arbitrary element in the intersection of their images. That is, y belongs to fu and y belongs to fv. Now, by applying the definition of the image, we see that there exists some x1 in u such that y is equal to fx1. Similarly, there exists some x2 in v such that y is also equal to fx2. In other words, we have achieved that fx1 is equal to fx2. However, recall that we have assumed f is an injective function. Thus, this indicates x1 is equal to x2. Now recall that x1 belongs to u, x2 belongs to v. However, now that they are the same element, it belongs to the intersection of u and v. Thus, y is in the image of the intersection. This justifies the set inclusion of the other direction. As a consequence, we have proved the desired identity. This finishes the proof for the only if part. Next, let us work on the if part. So let us assume that for arbitrary subsets uv of A, this equality indeed holds. From there, we show that f is indeed injective. Let x1 and x2 be arbitrary elements in A, such that fx1 is equal to fx2. To simplify our description, let us also denote this common function value by y. Now, let us pick U to be the singleton set consisting of only x1 and V to be the singleton set consisting of only x2. Now, clearly, fu is just the singleton set consisting of y. So is fv, since we have assumed that both fx1 and fx2 are equal to y. Now, from the assumed identity, we see this implies that the image of the intersection is also this singleton set. In particular, this implies that the intersection of u and v cannot be empty. Otherwise, the image of an empty set will be empty, leading to a contradiction. But now notice that u only consists of x1 and v only consists of x2. So if their intersection is not empty, that means x1 and x2 are identical. In other words, f must be injective, and the if part is proven as well.